Hello everyone, very good evening and welcome to the BYJU'S exam prep. This is Sanjay Rathi. Now, today we will discuss amplifiers from Sadra and Smith. Okay, already we have discussed number of topics from Sadra and Smith like what BJT, MOSFET, and now this is amplifier by using BJT and MOSFET. And after that I will take one session that is on what diode, guys. Okay, now this is a session, GATE 2024, questions from Sadra and Smith on amplifiers. Guys, and that is my introduction, myself Sanjay Rathi, and I am having 23 years of teaching experience. These are my ranks in engineering services exam, and according to my experience, you have to solve some selected numericals only from standard textbook. It will boost your confidence and you will get idea about new type of questions. Okay, and that is, therefore this is series for you. And if you want the PDF of this session, then this is my Telegram channel, that is Electronics by Sanjay Rathi. You can join now, and remember I will upload the PDF of this session on this Telegram channel, as well as if you have some doubts, then you can ask your doubts and queries on this Telegram channel, and you will get notification about any coming exams on this. Okay, and okay then this is the result in engineering services exam, guys, and congratulations all the students. Then this is the first rank in civil and 9th rank in what mechanical branch, and this is our results, guys. So you can also crack this engineering services exam. It is highly prestigious exam, and if you want to become class 1 officer, then you can start your journey now, or you can also start your journey with us. And remember, there are 3 phases: pre, mains, and finally what? Interview. An interview is going to play a crucial role in your selection. So start your preparation as early as possible, and anyone can crack this exam, guys. But you have to start now. Then this is first question. Questions from Sadra and Smith, that is the amplifiers. Guys, remember this is a question from example number 3.17. I think you have this book. Okay, and how to solve this question? Please try to solve this question, everyone. Try to solve this question on amplifiers. Now, already I have shown you, this is the book Sadra and Smith, 6th edition, right? And you have to solve some solved numericals and unsolved numericals from this. And now this is amplifier. Here I will give you the idea about what is the pi model, RE model, and what small signal model for MOSFET. We are using the pi model or RE model, that is also known as T model, for BJT. And then we will use one small signal model with transconductance ZM and drain resistance RD for MOSFET. So that is the first question on your screen from BJT. Now tell me what is the answer. You can say, sir, diagram is not given. Yes, but standard circuit it is written here, and this is the example number 3.17. You can also note the page number 255. What is given here? Common emitter amplifier utilizes a BJT with beta 100. What is the common emitter amplifier? Means we are giving input to base and we are getting output from collector. That is called common emitter. Bias that IC is equal to 1 milliampere. Current is also given 1 milliampere and has a collector resistance 5 kilo ohm. Find input resistance, output resistance, and internal gain. If the amplifier is fed with a signal source having a resistance of 5 kilo ohm and a load resistance of 5 kilo ohm is connected to the output terminal, find the resulting AV, that is called, after connecting the RL, what will be the gain? Then what? GV, overall gain, that is the symbol GV, AV. These are the symbols what in Sadra and Smith. Otherwise in Milliman Healthcare we are using AVS, that is called V0 by Vs. In GATE exam they will ask find the exact V0 by Vs or V0 by VE, right? Or normally they are saying what is the mid band voltage gain, right? So I will give you the idea about all this type of terminology here. If V pi is to be limited to 5 millivolt, what are the corresponding value of Vi signal and V0 with the load connected? Okay, so what is the meaning of this? You will get the idea. Now, first of all, yes, Now what is the RE model? What is the RE? 1 minute. Okay. Then this is the RE. Common emitter. What is common emitter configuration? This is common emitter configuration. We are getting output. This is RC. This is VCC. Value of VCC is not given, right? Then value of IC is given 1 milliampere and has a collector resistance of 5 kilo ohm. This is the collector resistance of 5 kilo ohm. IC it is given 1 milliampere. Okay, this is given 1 milliampere bias that. VA early voltage is given, and then you have to find R in, R naught and AV naught without any. This is the second question where we are connecting. Now this is the case. Nothing is connected here. Then what we can say? What is the first of all you have to find R pi. R pi, then GM. So what is the GM? IC by VT. Now calculate, use your calculator. Use your calculator and give me the value IC by what? VT. VT you can use. What is the temperature? Normally these days we are taking the temperature is equal to what? 25 degrees centigrade. Then what? This is the 25 degrees centigrade. Then it is 298 degree Kelvin. So what is the value of the VT here? KT by Q. KT by Q means when we are putting the Boltzmann value of the Boltzmann constant value of the Q, then it will become T by 11,600 and volt. When we are putting the 298, VT is coming to be 0.025 volt at 25 degrees centigrade. Remember this value. So you can use this value and you can find, 1 minute, give me 1 minute. You can find the value of what? GM. So GM is 1 divided by 0.025. Remember this is in what? Milliampere, and this is in volt. So milliampere per volt. So what is the value of the GM? 1 divided by 0.025. You will get 40. This is called transconductance, 40 milliampere per volt. Okay. Now R pi. R pi is beta by GM. So what is the beta here? Beta is given as 100. It will become 100. So that will be the question in gate. Find the value of the R pi and so on. 40. So milliampere will become kilo ohm. This is the 2.5 kilo ohm. What is the value of the R pi? 2.5 kilo ohm. And what is the value of the GM? 400 milliampere per volt. Now VA, if the VA is given, early voltage is given, means you have to find the R naught, output resistance. With the help of that we have to find the R naught, VA upon IC. 100 upon 1. Normally this type of questions we are getting in gate exam. So it is what? 100 kilo ohm. Because it is in milliampere, then it will become what? 100 kilo ohm. Now we have these values. So can we draw the model here? Yes, we can draw the model here. What is the model here? Pi model. So pi model is GM V pi and this is R naught. This is R pi here. This is R pi and the voltage at this point is V pi. Okay, this is base and that is collector. Now from collector to ground, from this is the when we are doing the DC and AC analysis, this is 0. So from collector to ground, one RC is connected. This is RC is connected here. Now here we want, in first question here we want V naught without any RL, and we have not connected VS. So what is the R in up to this point and what is the voltage gain? So what is in first question what is asked? RC 5 kilo ohm, find the R in, R naught and AV naught. AV naught is called internal gain. So what is the meaning of that? After that we have connected the RL and signal. So what is the R naught, R in and AV naught? So here, what is this R naught? Okay, overall resistance. Then what is the R in? R in is directly we can say R pi. V pi by I in, that is the R pi 2.5 kilo ohm. That is the answer. Remember, this is a 2 marks question for electrical electronics student instrumentation branch. Then second thing, if what is the voltage gain? So V naught by V pi. This is called V naught by V pi. It is given by AV naught. But in question they will give you the ratio. Find the V naught by V pi. V naught by V pi, how we can find? This will become minus GM V pi. Minus GM V pi. R naught and RC in parallel. You can write minus GM V pi R naught parallel with RC upon what V pi. V pi cancel, and that will become minus GM R naught parallel with RC. You can directly use this formula. And what is the R naught? 100 kilo ohm, RC is 5 kilo ohm. 100 parallel with 5 means it is 500 divided by 105. 105. So 500 divided by 105, 4.76 kilo ohm. And what is the value of the GM? 40. So when it is multiplied with the 40, you will get the voltage gain 190.476. It is the internal voltage gain 190.476 without RL, without signal, right? And that is the basic diagram it is called. So it is a very high gain with 180 degree phase shift. It is very, very high gain with 180 degree phase shift, guys. Okay. Now, any doubt up to this point? Anyone, any doubt? This is a 2 mark question, guys. Simple, by using the R pi model. Now, what is given here? This is, and what is the we have find what is the R naught then? What is this? Is the AV naught. Then R naught up to this point, if you want to find what is the voltage, then this R naught and RC are in parallel. That is called R naught. So this is nothing but R naught. So we have find the R in, AV naught and R naught for basic diagram. Now, in next part what we are doing, if the amplifier is fed with a signal source having a resistance of 5 kilo ohm and a load resistance 5 kilo ohm is connected to the output terminal, means in this diagram, now we have to connect. So for this same diagram, already we have find the GM R pi. Here we are normally we are connecting the load with the capacitor. Under AC analysis, this capacitor will act as short circuit. This is RL. Here we are getting the output. Again common emitter. Up to this point we have find the RI. Now we are connecting RS. Here we are connecting RS and VS. This is the VS with signal with source resistance RS. And what is the source resistance? 5 kilo ohm it is given. And what is the load resistance? It is also 5 kilo ohm. This is 5 kilo ohm. This is 5 kilo ohm, guys. Okay. Now, if you have the two values 5 kilo ohm and 5 kilo ohm, then what is the change in the model, guys? Now, if you want to make a model, a small signal model, so what is the change in the model? Very, very simple one. Draw the diagram GMV pi here. Then you can, this is the case, R naught, RC is already connected here. Now this resistor, because this capacitor will act as short circuit, VCC is 0. From collector to ground, RC is connected. From collector to ground, RL is also connected, 5. So this resistor is connected parallel to RC. RL. Now, if this question is given in GATE exam, then directly R0, RC and RL all are in parallel. And what is the current here? Minus GMV pi. Now here, this RS is connected. This R pi, already this is the R pi is the part of the network. What is the voltage here? V pi. And now this is Vs is connected here. And this resistance is Rin. Rin is nothing but R pi. This is Rs, 5 kilo ohm. 5 kilo ohm. So very basic question of 2 marks. Then it will become, how we can find again? This is a very small signal model. Just use the concept of network to get the mid-band voltage gain. Now, what is the output resistance up to this point? Already we have find. Now this is RL is parallel. So guys, what is the V0 by V pi? Directly this is called AV. And what is given in the question? Yes, AV. If the amplifier fed with, find the AV. This is called AV. And then what is the GV? Overall voltage gain. So AV is called V0 by V pi. So AV is called V0 by V pi. So what is the V0? Minus GM V pi. R0 parallel with RC parallel with RL. Very, very simple. All the three resistors are in parallel. Remember, the value of these resistors are 100, parallel with 5, parallel with 5, 2.5 parallel with 100. You can find upon V pi. So V pi cancel and you will get the voltage gain here. Minus Z pi GM. So minus GM R0 parallel with RC parallel with RL. Okay. Now, what is the value here? Value of this R0, 2.5 into 100 divided by 102.5. So you will get around 2.439, highly reduced voltage gain, and this is multiplied with the 40. Then voltage gain will become 97.56. 97.56. What was the voltage gain without RL? Without RL, the voltage gain was what? 190.476, just half. Right, just half, because of connecting the RL. When we are connecting the load, there is a drastic change in the internal gain of the amplifier. Then what is the effect of this RL signal? What is the overall gain? When we want to find the overall gain, that is called GV or AVS, that is called V0 by Vs in this diagram. Now finally, what is the V0 by Vs? That is also known as mid-band voltage gain. In GATE exam, normally they will ask what is the V0 by Vs. Then this is called GV in Sedran Smith, AVS, another name V0 by Vs. So V0 by Vs is nothing but V0 by V pi into V pi by Vs. V0 by V pi is what? Gain, AV. And what is the V pi? According to voltage division rule, input resistance is R pi upon Rs plus R pi. Rs plus R pi. This is the relation between V pi upon Vs. V pi according to R pi upon R pi plus Rs. So what is the overall voltage gain? This is minus 97.56 into R pi. What is the R pi here? R pi, that is already we have find 2.5 kilo ohm. 2.5 upon Rs is 5 kilo ohm. This is given 2.5. This is 5 kilo ohm. Now what is the overall voltage gain because of all these? Then you will get 2.5 divided by 7.5, that is 1/3. of 97.56. 32.52 only. 32.52. This is the only voltage gain here. So user required what? Overall voltage gain, and that is very, very small as compared to internal voltage gain, that is the 197. So when we are connecting, when we are not connecting RL or VS and RS, that gain was what? 190.476. 190.476. Once RL is connected, again the gain reduces up to what? 97.56. Again when we are connecting the signal, then gain reduces what? Minus 32.52. In one numerical, we are getting the idea that what is the effect of RL and what is the effect of RS. Now what is the problem here? Why so difference? Why so difference? Internal gain is very high, but overall gain or midband voltage gain, that is useful quantity for user, because user want what? Only V naught by Vs. It doesn't matter what is the internal gain. So V naught by Vs is very, very less as compared to internal gain. Then input resistance is very less. Input resistance is very less means this R pi is very less as compared to this RS. Therefore, 1/3, we are getting the 1/3 voltage here, remaining voltage will wasted. Yes, 2/3, 2/3 voltage is wasted across what? RS. And that's why we are getting the very less overall voltage gain, guys. That is the problem. Second problem is what? The load resistance is what? Too low, 5 kilo ohm. So 5 kilo ohm parallel with 5 kilo ohm, and because of that overall resistance will become 2.5 kilo ohm. When the output resistance decreases, voltage will decrease, because V naught depends upon what? The parallel combination of R naught, RC, RL multiplied with what? GMV pi. That is the reason. So hope you have enjoyed this question, everyone. Any comments if you want? If you want to ask any question related to this, one question, in one question you are getting number of questions, right? And then okay, anyone, any question? Fine. Please try to solve. This is on pi model, and that is the question number. Okay. Now what is the next question? If the up to this point it is over, if V pi is to be limited to 5 millivolt, we want that V pi should be only 5 millivolt. What are the corresponding V signal and V naught with the load connected? Corresponding signal. So guys, if this V pi is limited to 5 volt, if here you want 5 millivolt, so according to voltage division rule, what we have to apply? Vs here. So what is the relation between V pi and Vs? We have idea. According to next question, if you want V pi 5 millivolt, then what should be the applied signal? Already I have said, according to voltage division rule, this R pi is only 2.5, this RS is 5, here you want V pi, so V pi is equal to only 5 millivolt it is given, that is nothing but according to voltage division rule, Vs RS plus R pi into R pi. Now what is the value of Vs it is required? So Vs is equal to RS plus R pi upon R pi into V pi. So this is 5 plus 2.5 upon 5, 2.5 into what? 5 millivolt. So this is nothing but 3 into 5 means 15 millivolt. We have to apply 15 millivolt at the input. When this is the 15 millivolt, 10 millivolt will lost across the RS and 5 millivolt will come across this. Okay. Now what is the output voltage when RL is connected? So as you know, what is the overall voltage gain? Overall voltage gain V naught by Vs is minus 32.5, minus 32.5. This is not the overall voltage gain. We have find the overall voltage gain. Where is the overall voltage gain? 1 minute. Minus 32.52. Minus 32.52. So what is the V naught? For 15 millivolt, you can find a 32.52 into what? 15. That will be the answer in what? Millivolt. Now you can find 487.8 millivolt. And that is the value of the output voltage, negative because there is 180-degree phase shift. This is the complete question. So no doubt they will not ask the full length question, but with one question we are getting what is the mid-band voltage gain, what is the effect of the low input resistance. Because of the low input resistance, overall voltage gain is very less as compared to internal voltage gain. When we are connecting the load, again the gain will change. That is called what? Loading effect. When we are connecting the RL, the gain will just become half of the internal gain. That is called loading effect, guys. Okay, then now next question. Next question. I am going to solve the next question. So this is the question. Okay. So nearly equal to, this is the answer 0.487. So we can say nearly equal to, if it is asked in volt up to two decimal places, then you can write 0.49 millivolt magnitude of V0. 0.49 millivolt, and in negative this is the negative value if your amplitude is required. Then guys, next question. So how we can increase the input resistance? We can increase the input resistance by connecting what? RE. By connecting RE, or in this question I am going to give you the idea about the RE model, or that is called what? T model. Now for the common emitter amplifier specified in example 3.7, means just in previous model, what value of RE is needed to raise RE into a value 4 times that of the signal? What was the R signal in previous question? RS was 5 kilo ohm. Now we want to increase the input resistance. Initially it was only R pi, that is the 2.5 kilo ohm. Now we want to increase 4 times of the R signal, that is 20 kilo ohm. We want to increase it up to what? 20 kilo ohm. Initially it was only 2.5 kilo ohm, half of the RS. Now we want to increase. What is the formula? With RE included. The first question is what is the value of the RE. So we will solve this question, and then we will find the internal gain. What is the effect on the internal gain? What is the effect on the R0, AV, GV? All we will find. And what is the V pi is limited to 5 million. What are the corresponding value of V signal and V0? Overall voltage gain we will find. Then what is the RE? This is the connection here. We are just connecting RE here. What is the value of RE it is required here? And here we are connecting the RS. This is Vs. Same value, because nothing is given in question. So RC is also 5 kilo ohm. VCC, IC is equal to 1 milliampere. One load is connected here. The value of that load is what? 5 kilo ohm. Here we are getting the output. Okay. Now, this is RS 5 kilo ohm. Here RI. Here RI. Okay. Now, IC is equal to 1 milliampere. That is given in the question. In first question it is given IC is equal to 1 milliampere. Now, IC. This is IC. DC biasing current is given as 1 milliampere. Now, beta is very large, 100. So, you can neglect the beta, and you can find that in this case, we are going to use the RE model. So, what is the RE model here? RE, small RE. That is given by VT by what? IE. IE is nearly equal to IC. It is the 25 millivolt upon 1 milliampere. I is nearly equal to IC. You will get the 25 ohm. 25 ohm. So what is the RE model? Here you are using alpha I 10. Alpha, this is the base. Here we are connecting the small RE. And that is the emitter terminal. This is the collector terminal. Now, from emitter, this is the emitter terminal. From emitter to ground, capital RE is connected. For collector, this is also ground. During AC analysis, it will act as 0. From collector to ground, RC is connected. This capacitor is called coupling capacitor. It will act as short circuit. From collector to ground, RL is connected. Now, this is connected. Here it is. Then, one collector to ground, RC is connected. Collector to ground, RL is connected. And that is the use of what? RE model. These two are in parallel. And that is called V0. Here, signal is connected from base to ground. And this is Vs. Okay. That is the complete diagram by using RE model, small RE model, right? And this is also called T model. So RE already we have find 25 ohm. Alpha is what? Beta upon 1 plus beta. So beta is given as 100. So 100 upon 101 nearly equal to 1. You can say it is nearly equal to what? 1. Okay. Then here the current is I. So what is the current in this direction? Minus I, because nearly equal to 1. Base current we are neglecting. So what is the current here? IE. What is the current here? IE. And that base current is what? IB. So remember, from this point to this point, what is the input resistance? For example, if you are choosing the V in, so input resistance that is asked in the question, input resistance is given by V in upon IB. V in upon IB. Then input resistance is 4 times of RS, that is given by V in upon IB. You can write V in is equal to, write down the KVL, you will write IE into small re plus capital RE. What is the IE? You can write 1 plus beta times of IB into RE plus RE, because emitter current in active region is given by 1 plus beta. So what is the R in? Standard formula V in upon IB. That will become 1 plus beta times of this RE plus RE. Now, if you have the formula of R in 2 marks question, what is the value of the capital RE? So that we are getting the resistance 4 times that of the source resistance. So what is the 4 times of the source resistance? That is the 20 kilo ohm. 4 times of the source resistance, that is nothing, 25 kilo ohm into 4, that is the 20 kilo ohm. Beta is 100, RE is 25. Now you can put the value. So RE will become 0.025 kilo ohm, 25 divided by 1000, plus capital RE it is required. That will become 20 divided by 1 plus beta, 20 divided by 101. What is the capital RE? Now you can find. 20 divided by 101. Minus 0.025. It is in around 0.173 kilo ohm. That is the answer. 0.173 kilo ohm. Okay. And this is the question, or nearly equal to what? 175 ohm. Nearly equal to what? 175 ohm. Because that 1 plus beta, they will take what? Nearly equal to 100, and that is the divided and so on. You will get the 175 ohm. That is the answer given. So this is the answer for what? RE. Capital RE is required if you want to increase the input resistance up to this point. Initially the input resistance are only 2.5 kilo ohm. Now the input resistance is 20 kilo ohm, means when we are connecting RE, input resistance will increase. Now, what is the gain? What is the voltage gain? V0 by V in. If you want to find the V0 by V in for this particular question, then this will become V0 by V in. Just according to gate point of view, I am giving you the what they will ask. RC and RL are in parallel. This is 5 kilo ohm, this is 5 kilo ohm. For example, if these two are in parallel, 5 kilo ohm parallel with 5 kilo ohm, it will become 2.5 kilo ohm. And this I is multiplied, so output voltage will become minus I RC parallel with RL upon what is the V in. V in is what? This is the voltage I into RE plus RE. Suppose you want to consider the alpha, so that actually the output current is what? Alpha I minus alpha, because this is the current is minus alpha I. So we are taking the alpha is equal to 1, otherwise you can write minus alpha I. Okay. Then this I cancel and it will become minus alpha. This is the standard formula, RC parallel with RL upon RE plus capital R. Now alpha is nearly equal to 1 because beta is very large, and what is this? 2.5 kilo ohm RC parallel with RL upon small re 0.025, 25 ohm plus 175 ohm. This is in ohm, this is in kilo ohm, so convert it into ohm. So 2500 ohm upon nearly equal to 200, 25 by 2. What is the gain? 12.5 with minus sign. Gain is 12.5 only. Please check my calculation. Gain is 12.5 only, and that is called what? Gain with what? Capital RE. So what is the gain? Very, 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 very low, guys. Very low. Initially it was the very high gain. Now gain decreases, but the system is highly stable because we are getting the feedback across capital RE, negative feedback. What is the role of the capital RE when we are connecting? Input resistance will increase, but the gain will reduce. So that is the gain. That is the gain, guys. Okay. Now it depends upon what RE, small RE, but this small RE is very, very less as compared to capital RE. So you can ignore it, and it is independent, almost independent of transistor parameter. Finally, this is the V0 by V in. What is the overall voltage gain? Overall voltage gain is given by, always remember this thing. Here it is Vs. Here it is Rs. Here we have find Rn. Rn is nothing but 4 times of Rs. This is Rs. Already we have proved. And this voltage is Vin. So what is the overall voltage gain? That is called AVS, and this is in this book it is called GV. That is the V0 by Vs. V0 by Vin into Vin by Vs. And already we have find minus 12.5 V0 by Vin. What is the Vin by Vs? Rin upon Rin plus Rs. And it will become minus 12.5 into, what is the Rin? 4 times of Rs. Upon 4 times of Rs plus Rs, it will become 5 times of Rs. Rs cancel, it will become 4 by 5 times of. What is the overall voltage gain? 4 by 5 times of 12.5. 12.5. Now find the value. Very, very simple one. And that is called what? Overall voltage gain, guys. So what is the overall voltage gain here? Now you can use your virtual calculator. Nearly equal to 10. One minute. Okay, this is 50 divided by 5, 10. With 180-degree phase shift. So initially the overall voltage gain was what? 32.5, and now it is only 10. Means there is a reduction in the gain. There is a reduction in the gain, guys. Now, what is the asked in the question to justify it? If the V pi is limited to 5 millivolt, what are the corresponding values of the V signal and what V naught this time? Again, same question. Now, if you want this voltage 5, then what is the value of the Vs? Now, in this case, you can find the value of Vs, guys, and also you can find the value of what V pi, and then you can compare it. So, because once the input resistance increases, once the input up to this point, they will ask question in gate examination, because that model is applicable. So I have given you the idea, because no need to solve each and every point of the textbook, no need to find each and everything from the textbook. How to use the model, that is important. How to use the model, small signal model, RE model, T model. So already I have given how to find the input resistance, what is the effect of the capital RE, what is the effect, how to use the T model, and so on. Okay then. Next question. Next one. Okay, if you want, just after that, I'm going to take one session on diode circuits. As you know, diode circuit is very, very important for all branches, whether it is electrical, electronics, or what instrumentation branch. So I have one session, again, number of questions from standard textbook, that is what Sedran Smith and Millman Halkias, and ready to solve some questions. Then if you want, then write in comments that yes, we want to solve some questions. Okay. Like the session and share the link of this session. Now, the next question, always remember you have to use the voltage division rule to find the overall voltage gain. So that is, normally in numerical, they will ask what mid-band voltage gain. They will simply use the word mid-band voltage gain. Mid-band voltage gain is nothing but V naught by Vs. Overall voltage gain. Sometimes RS is given, sometimes RS is not given. If the RS is not given, then that internal gain will become overall voltage gain. Minus 12.5 will become overall voltage gain if the RS is 0. Okay. Okay, so before entering into the next question, guys, this is a very, very important information for you. If you want to start your journey with us, if you want to get the top rank in engineering services or what other competitive exams like GATE, ISRO, DRDO, then you can start your journey with us. And that is what Gateway National Scholarship Test for GATE exam. Get up to 90% off on our program on 26th of November, means coming Sunday, right? And window will be open from 9 AM to 9 PM. Register now, link is given in description. But before that, you can install BYJU'S exam prep from Google Play Store, okay? Second thing, workshop. Free workshop, guys, by Dheeraj Sardana sir, MTech from IIT Bhopal, and this is a highly experienced faculty. On 29th of November at 7:30 PM. Okay. Strategy to secure AIR under 100 in GATE 2025. Register here for this workshop. Okay. अरे आपके जो भी क्वेश्चंस है आपके दिमाग में रिलेटेड टू GATE 2025, you can ask. वैसे बता दें ये राइट टाइम है. This is the right time to start your preparation for national level exams like GATE exam. Okay then. Now, that is the conclusion that is given in what standard textbook, that is Sadiku. But it is very, very difficult to recall all this formula during exam. But you can, when we have the model, for example, RE model or pi model, try to solve the question, try to use those model, and you can verify whether you are getting the same formula, yes or no. If you are getting the same formula, then means you have the command over that. For example, RE. What is the value of the RIN for common emitter only? This common emitter with RE, common base, emitter follower means common collector. 1 plus beta times of RE, that is nothing but R pi. So sometimes we are saying that this is the input resistance R pi, 1 plus beta RE. What is the voltage gain? What is the output resistance? Then what is the internal voltage gain? Then what is the overall voltage gain? So these are the formula. Draw the model, verify it. You are getting the same answer. In exam hall, you are going to get the same answer with numerical values. And we have only 4 main diagrams. One is what? Common emitter. Another one is common emitter with RE. Third one is what? Common base. And fourth one is what? Common collector. Right? Common collector, that is called emitter follower. So draw the small signal model for all these 4. Solve this and get this answer and verify it. If you find any difficulty, then please inform me. And if you want session on that, that how to solve this question, how to draw the models, small signal models, and how to get this answer, then I will arrange one session for that. Okay, don't worry. So please pin me on my Telegram channel, that is Electronics by Sanjay Rathi. So this is just a conclusion. This conclusion that is given in Sedra & Smith. And if you want a PDF, again that will be available on my Telegram channel. Now, next question. Next question is, it is required to find, what is the word used here? Mid-band gain, mid-band. And the upper 3 dB frequency of the common emitter amplifier for the following case. VCC is given, VEE is given, I 1 milliampere, RB 100 kilo ohm. In the diagram, I will give you the diagram. RC 8 kilo ohm, signal 5 kilo ohm, RL 5 kilo ohm, B0 100, beta is 100, early voltage is 100, C mu 1 picofarad, FT, that is called unity gain bandwidth product, 800 megahertz, and Rx is equal to what? 50 ohm. These are the values given. So now, what is the diagram number? That is the 3.84. I am going to draw and try to solve this question. 3.84. This is the figure number 3.84, guys. Okay. Now, this is the diagram given here. Okay. One current source is given here. This is minus VEE. This is VCC. This is RC. RB is connected here, and one signal, RS signal, and this is VS. This is called signal voltage and signal resistance. It is connected here. Right, and this is connected here. This is the diagram, and one capacitor is connected and RL is connected here. This is called coupling capacitor. This is connected here. This diagram will be given in the question. So what is the given? Mid-band gain and upper 3 dB frequency. VCC and VE are both 10 volt, 10 volt. This is minus 10 volt because VE is 10 volt, that will become minus 10 volt. IE is what? 1 milliampere. This current is 1 milliampere. Then common emitter figure for the following: RB 100 kilo ohm, RC 8 kilo ohm, RC 8 kilo ohm, RS 5 kilo ohm. This is given in the question. Signal 5 kilo, RL 5 kilo ohm. Kilo ohm. This is coupling capacitor. Beta 100, VA 100. Right. Now, what is this? How we can solve this question? Then, first of all, what is the R naught here? Right. So now, watch this current. Beta is very, very large. Then you can say this is what IE. What is the DC current IE? Nearly equal to 1 milliampere. Then IC is also 1 milliampere. IC and IE are equal. If we are neglecting the base current, so IC and IE are nearly equal. Then you can find R pi. First of all, you can find RE. VT by IE. That is equal to 25 millivolt upon 1 milliampere. Milli cancel, it is 25 ohm. Second thing, GM. Remember GM. What is the GM? Mod of IC upon VT. 1 upon VT. That is nothing because IC is nearly equal to IE. So it is nothing but nearly equal to what? 1 by RE. When we are finding the reciprocal of that, you will get 40 milliampere per volt. Same value. 40 milliampere. Remember, GM is nearly equal to 1 by small RE. That is called resistance. Now, GM. We have the small RE and GM. Now, 1 milliampere. Because of that, what is the output resistance R0? This is given by VA upon I. 100 upon 1, that is 100 kilo ohm. Because it is in milliampere, 100 kilo ohm. This is the output resistance because of the early effect that is based with modulation. Now, we have all the values. Then, what is asked here? Signal 5 kilo ohm RL beta naught VA. It is required to find the mid-band gain. What is the meaning of mid-band gain, guys? So first of all, what is the frequency response of this amplifier? This type of frequency response, just like a band pass filter we are having. This is the frequency response. Here, gain reduces. This is the case. This is called mid-band area. This is called mid-band area here, from this point to this point. Okay. Here, mid-band. At this point, we want gain, that is called mid-band gain. Okay. And then this is called low frequency area, where the gain will fall due to what? Coupling capacitor. So we are getting the reduction in the gain because of the coupling capacitors. Or at this end, we are getting the reduction in the gain because of the diffusion capacitance, transition capacitance. This is also called C pi, C mu. So this is the diffusion and transition capacitance, wiring capacitance and stray capacitance. That is the gain in fall. Okay. And now, this is called bandwidth. FH minus FL is called bandwidth. Normally, FH is very greater than FL. So, bandwidth is nearly equal to what? FH. Nearly equal to FH. So, this is called what? When in particular question, if it is asked what is the mid-band voltage gain means, you have to find gain at this point. It is just like a band pass filter. At lower side, the gain will reduce because of this capacitor. At higher side, the gain will reduce because of this capacitor. Okay. Second thing, at this point, it acts as a high pass filter. At this point, it acts as a low pass filter. It acts at high frequency, it acts as a low pass filter. So, first of all, mid-band voltage gain means no need to consider all these capacitor because CC1, CC2 act as short circuit in mid-band. Act as short circuit, to make it short circuit, and all the internal capacitance C mu, C pi will act as what? Open circuit. So no need to consider these, and simply draw the small signal model, RE model, and you can find the gain. Now we have all the values. Then how we can find the gain? Then because R0 is also given, then you can find the mid-band voltage gain, guys. So this is the question. Already I have find the values here. Okay, so which question it is? 1 minute. That is the example number 3.21. It is required to find the mid-band gain and upper 3 dB frequency. Already I have given. Now guys, we are going to use the pi model. We are going to use what? Pi model here. Then this is the connection here. What is the pi model? Here we are having R pi. This is V pi. Here we are having the RB, that is called base splitting resistance in pi model. This is also known as RX. Base splitting resistance. This is the base. This is emitter. Here GM V pi. We have find the GM V pi. And then this is R0. No. This is the model. What is the value of the R pi? You can find the value of the R pi also. Beta by GM. So R0 we have 100 kilo ohm, RE we have 25 ohm. You can also find the R pi, that is R pi is nothing but beta by GM. Beta is given as 100, GM is given as 40. Initially we have already find 2.5 kilo ohm. So what is the value? 2.5 kilo ohm. You can use this 2.5 kilo ohm here. Now RS is connected here. Watch this. From base to ground, RB is connected, and then base to ground RS and VS is connected. So you can connect the RB here. What about the emitter? Watch this. Then this battery will act as what? Short circuit, so you can remove it. Then this is the case, RS and VS is connected, so you can connect RS and VS. Finally, at this point, from collector to ground, RC is connected, from collector to ground, RL is connected. 8 and 5 are in parallel. This is the RC 8 kilo ohm, RL 5 kilo ohm, and here we are getting the V0. Okay, so this is the diagram. So what is the mid-band voltage gain, guys? Mid-band voltage gain means in numerical, this is a 2-mark numerical, you have to find the V0 by Vs. Then you have to first of all find V0 by V pi, right? Then you have to find V pi by Vi. This is the Vi. V pi by Vi. Then find V pi by Vs. So you can see what is this, sir. Then this is the V0 by V pi up to this point, and V pi by Vi, the ratio between these two resistors, and then finally Vi by Vs, that is the ratio. Now up to this point, what is the Vi? This is the voltage Vi. So you can find a value. What is the V pi by V pi? Just I am giving you the answer. Because up to this point, what is the resistance? Vi. That is the difference of voltage division between these two. So it will become R pi upon R pi plus Rx. Rx is given in the question. So V pi by Vi, this is the R pi upon R pi plus Rx, or base splitting resistance. Second, now up to this point, what is the resistance? Rin. This is called Rin. Rb parallel with what? R pi Rx plus R pi. So Rin is given by Rb parallel with Rx plus R pi. Okay, then find the Rin. Then once you have the Rin, so what is the ratio between Vi by Vs? Vi by Vs, you can use Rin upon Rin plus Rs. This is the voltage division between these two. Now you have the value V pi by Vi, because we have the value of R pi 2.5, Rx is equal to 50, you can find this value. Now you have the value of Rb that is given in the question, Rb, R pi, everything is given, you can find this Rin. Rin upon Rs plus Rin will give you the Vi by Vs. So you have this term, you have this term. Find these values. Now what is the V0 by V pi? So V0 by V pi, so this is the GM V pi minus GM V pi. You have the value of the GM, you have the value of R0, RC, RL. These three resistors are in parallel. So you can write the V0 is equal to easy question. Once you are able to draw the model, then the question will become what? Very, very easy. So what is the question here? You can write AV V0 by V pi, that is minus GM V pi R0 parallel with RC parallel with RL upon V pi. This V pi cancel out. Minus GM. What is GM? 40 milliampere. What is the R naught? 100 kilo ohm. What is the RC? 8 kilo ohm. What is this? 5 kilo ohm. Can you find this value? And that is called what? AV. That is called what? AV. Very, very simple one. So use the model and you can find. Just it is given in the question. Please verify it. And then after verification you will get. After verification you will get the gain around 120 nearly equal to, because that parallel combination is given as 3 kilo ohm minus 120 nearly equal to volt by volt. Volt by volt is unitless quantity. Now you have the 120 volt, then finally this divided by that you can multiply, and that is, it is given in the overall voltage gain. If it is given, then around what, minus 39.9. please verify it. Minus 39 finally the overall voltage gain, right? Yes, the overall voltage gain is given as minus 39.9 volt per volt. So the gain will reduce because of this voltage division rule, because of this voltage division. Find this value, and this is minus 120. When these two are multiplied you will get minus 39 gain. Now what is the relation between, the next question is what? This is for especially for electronics branch. What is asked? For the following case, VCC it is given, RX it is given, VAS it is given. You have to find the upper 3 dB frequency of common emitter amplifier. If it is asked what is the upper 3 dB frequency, FH. Upper 3 dB frequency means this is called 3 dB cutoff frequency, FH. So what is the formula for the FH here? We have the values. Now FH is given by 1 by 2 pi, right? This is given by R pi, C pi plus C mu, 1 plus GM RL dash. We have the GM RL dash, means this is the value. GM RL, this is the GM RL dash. We have the GM RL dash is equal to what? Minus 120. Now we have the value C mu is given. R pi already we have calculated. R pi we have calculated. How we can calculate the, if the C mu is given, and how we can calculate the C pi then? Remember the FT. FT is called unity gain bandwidth product, that is given by GM upon omega t. GM upon 2 pi C pi plus C mu. So what is the C pi plus C mu? Is given by GM upon 2 pi FT. So GM is given 40 milliampere per volt upon 2 pi. And what is the unity gain product? It is given in the question. FT, that is called unity gain by 800 megahertz. And C mu is given as 1 picofarad. You can put here 800 megahertz. 10 raised to power plus 6. And it is a 40 millivolt minus 3. Then C mu is given as 1 picofarad. Then you can find the what? C pi. Right, C pi. But remember that is in farad. You have to convert it into that picofarad. Then you can subtract it and you will get the answer for what? C pi. Okay. Now you have the C pi. Just to calculate it. So you will get around C pi is equal to C pi plus, or directly, yes, you can find C pi is equal to 7 picofarad. 7 pico. Check my calculation. This is the, what is this? 40 divided by 400. So this is 40 raised to power minus 3 divided by 2 into shift pi into 800 raised to power 6. 7.95 into 10 raised to power minus 12 means nearly equal to 8 into 10 raised to power minus 12 farad. It is what? 8 picofarad. If it is 8 picofarad and it is C mu is 1 picofarad. So what is the C pi? 8 minus 1, that is what? 7 picofarad. C pi is the 7 picofarad. Now if you have the 7 picofarad, then you can write here FH. Use the formula here. Then it will become 1 divided by 2 pi R pi. What is the R pi? Values. 1 divided by 2 pi R pi. 2.5 kilo C pi. Remember, C pi is in picofarad. You have to convert it. What is the C pi? 7 picofarad into 1 picofarad. 1 plus GMRL. Already we have find the GMRL. That is the gain. Already have given GMRL 120. 120 plus value 120 into these two are in what? Picofarad, and that's why it is multiplied with what? 10 raised to power minus 12 overall value. This complete value is multiplied by 10 raised to power minus 12. Okay, this is the value. Now you can find the 3 dB upper cutoff frequency. Check my calculation and just I am giving you the answer. 754 kilohertz. That is the 2-mark question in GATE exam wise. 754 kilohertz. 754 kilohertz. So this is called 3 dB cutoff frequency. So this is actually a high frequency analysis of what? BJT. High frequency, and normally we are getting question from high frequency analysis for electronics branch. But for mid-band voltage gain, it is important for all branches, whether it is electrical, electronics or what? Instrumentation branch. Now, how many students you have patience to solve this type of questions? Not all the questions, not all the questions. You have to solve only selected numericals. Only selected numericals from standard textbook. I have solved just solved example for you. Go through it, get the idea how to, what should be your approach. Normally what we are doing calculation mistakes also. You have to change the unit, then again apply the unit, then you can find the values. These all are the standard formula, guys. Okay, just remove this, and that is the answer. This is the complete question. You can go through the recorded lectures also. Now, just enter into the next topic. Just I want to give you one important information. You can join this what? Mega mock test for GATE 2024 for all branches. That is live from the 25th of November up to what? 1st of December. Okay, and that is the schedule is given. And for more detail, that you will find a link in what? Description. Install the BYJU'S exam prep app from Google Play Store. Okay, and try to give all the mega mock tests. And I think you have started preparation for what? ISRO examination. Yes, then we are going to start very important session for you. Stay tuned with us, subscribe our channel so that you will get the notification, and also join my Telegram channel, guys. So that is a very important mock test for you. Now just I want to explain one more question, right? So that is on MOSFET. That is on what? MOSFET. Then just quick idea about that small signal model. Try to solve this question and give me the answer on my comments box. Consider an NMOS transistor fabricated in a 0.18 microprocessor with L 0.18 W2 micrometer. The process technology is specified to have the COX, that is called oxide capacitance, mu n it is given, VTH is given. Find the VGS and VDS that result in MOSFET operating at edge of the saturation with ID is equal to 100 microampere, guys. 100 microampere. So if you want to solve this question, guys, watch my previous lecture on MOSFET. MOSFET is very important topic. Okay, you are going to get question from that. Now, where I have given what is the condition for this saturation and so on, go through this condition. That is, what is the VDS when it is less than VGS minus VT, and VGS is greater than VT, that is called threshold voltage, then this is called triode region. triode. In previous session, I have solved a question on this. Go through my previous session. And then when the VDS is greater than or equal to VGS minus VT, and VGS is greater than VT, then it is called what? Saturation region. Saturation region. Okay. So one is what? Triode region. One is what? Saturation region. Okay. Then simply consider N MOSFET. Now name is not, diagram is not given, L is given, W is given, means W by L ratio is given. The process technology is specified, COX is given, everything is given. Find the VGS and VDS that result in MOSFET operating at edge of saturation with ID is equal to 100 microampere. Edge of the saturation means, what is the meaning of that? Edge of the saturation means this is the boundary of triode and saturation. Right? Exactly at the boundary of the triode and saturation. First of all, it is follow the linear ohmic region, then bending of the curve, then it will enter into the saturation. This point is called edge of the saturation. Right. At this point, what is the value of the VDS? VGS minus VT. At the edge of the saturation, this is called VDS minimum or VDS set required for the saturation. Okay, you have to find the value of VDS minimum or VGS minus VT. So you can find the VGS also. At the edge of the saturation, use the formula for the saturation, half of mu n COX, that is given in the question, W by L, that is also given in the question, VGS minus VT the whole square, that is we have to find the VGS, VT is given in the question, IDS is given in the question. So directly at the saturation, that is the formula. Find the VGS minus VT, that will give you the value of VDS for just at the edge of the saturation. And then from that you can find the value of what? VGS. Okay, this is a very, very important one. Directly you can find the values. So if you want any hint, then watch my previous session, guys. Watch my previous session on this. Then if the VGS is kept constant, find the VDS that result in ID is equal to what? 50 microampere. So what is the value of VDS? So that current will reduce up to what? 50 microampere. If you want to reduce the 50, means it will not satisfy that condition. If that will not satisfy the condition, guys, that will not satisfy the condition, then it will enter into what? Triode region. So what is, no doubt that current is what? VGS is constant, means this is the VGS, this is the curve for VGS constant value. If here the current is 100 microampere, so where you are going to find the 50 microampere? In this region, 50 microampere. And here when we are finding the 50 microampere, means it is in a triode region. It will enter into the triode region. Try to solve it question with what characteristics. It will give you more clarity how to solve the questions. So that is the question. So here you will get the 50 microampere. Now find the value of VDS at this point. VDS at this point where you will find 50 microampere for VGS constant. Then to investigate the use of MOSFET as a linear amplifier, let be the operating in saturation with VDS 0.3 volt. Find the change in ID resulting from VGS changing from 0.7 volt by 0.01 volt and by minus 0.01 volt, and that is called what? Small signal change. It is fixed, VGS is fixed at 0.7, now it is changed by 0.01 minus 0.01, that is the small signal change. Then what will be the change in the ID? What will be the change in the ID in a linear region? Linear region. To try to solve this question, give me answer on my Telegram channel. Otherwise, in next session, I will take one. I will give the description of this. Okay then. And guys, now this is a question on what? CMOS. Question on CMOS. That again, the CMOS is also very, very important topic. Then the NMOS and PMOS transistors in the circuit of figure are matched with. Matched means when the K and S, W by Ln are equal, threshold voltage are also equal, lambda is 0 means channel length modulation is 0 for both devices. Find the drain current IDN and IDP and the voltage V0 for Vi. There are three values, Vi 0 volt, 2.5 volt and minus 2.5 volt. Again, CMOS, that is important for electronics student. Normally they are getting question from this topic. Then you have to find the values. When we are giving the Vi 0 volt, what about the P MOSFET and P MOSFET, N MOSFET? Then put the 2.5, P MOSFET, N MOSFET, then minus 2.5. There are three reasons. One is triode, cutoff, and what? Saturation. What about these two MOSFET? Whether they are in triode region, cutoff region, or in what? Saturation region. Then you can find the value of V0, because this resistor is also given 10 kilo ohm, and that value is given. So yes, with the help of this you can find. Okay, so try to solve all these questions. If you want to put your descriptive answer, right, pura answer bana lo, question bana lo in a subjective like manner, and then send it to what? My Telegram channel, that is Electronics by Sanjay Rathi. Okay then. And if you want to give some mock test, then install BYJU'S exam prep from my Google Play Store. That is the leaderboard. You will get the idea about the leaderboard, how many students are participated in this, right, and what is your rank. Everything will be mentioned here. And if you want to start your journey, guys, then already we have started crash course for GATE 2024, as well as Vision GATE 2025 and 2026, live classes, recorded lecture, study material, practice quizzes, right, and finally mock test. So if you are following these 5 steps, automatically you will get the top rank in this exam. For more detail, you can call at this number, guys. This is my channel, Electronics by Sanjay Rathi. Okay then, thank you very much. Start solving question from standard textbook, but some selected numericals only. No need to solve all the questions. Okay? Okay then, thank you. Have a nice day.